So in this lab, we're going to continue our efforts to make the program even better. We have the same exact circuit setup. Nothing has changed. We have a DAC that's connected to port B, power transistor, to a light bulb, 10 millivolts per Kelvin, and the display is showing us the temperature in Celsius. Now, one of the drawbacks of the previous lab was as the potentiometer was turned, it had a jerky aspect to it. And the reason that happened was that the value that's being read from the pot was being read only about once every second because of the delays associated with the display as you went through the main loop of the program. And so as the user changed the value of the DAC, the light bulb's intensity would jerk up and down because it's only being read once per second. Now, to avoid that problem, we're going to eliminate that by using a timer interrupt. To incorporate a timer interrupt in this assembly language, the timer interrupt executes about 10 times per second if done properly. And in that timer ISR, we are going to read the value of the pot and update the DAC. So that's happening as I'm speaking right now, 10 times per second. So at 10 times per second, we should have a nice smooth transition with the value that's coming out from the DAC onto the light bulb. As I turn the pot, as you can see, up and down, it's very smooth. No jerkiness anymore because it's being updated 10 times per second. And the value that's being read and put onto the display should be transparent to the user. That is, it should look just like the previous lab. It's being updated as it was before. But the beauty of this is that we can now vary the intensity in a nice smooth fashion. And the display then updates the temperature as was before. This improved lab is a much better user interface in the long run for the end user when it comes to this open loop control system.